Now moving on to the next type of partial differentiation, which is using composite function. Now for composite functions, I have been drawn two diagrams for two variables and three variables. Now the upper apex of the square, which is towards the function z is equals to f of x flag, represent my function, whereas the opposite point represent my answer. So when I have to reach that point, I have two ways, by using x or by using y. So by using, I cannot go directly to that point, so we need intermediate steps, where my first step will be partial derivative, and the second step in that route will be a normal derivative with respect to x. So I will first convert the function into a partial derivative form, and after converting the partial derivative form function, I will take the derivative of function, and I can reach dou z upon dou t. Okay, the same applicables to the next route, which is using the y route if the variable contains two variables. So the y route will be as similar to the x route just I discussed, which is dou z upon dou y and then dou y upon dou t. So from these intermediate steps, we can find the value using first by partial derivative and then by normal derivative. Now if the function consists of three variables, then the whole scenario will be the same, but the number of roots will increase as the variable increases. So depending on these two, there are two types, the first order and the second order. We will be dealing with both in my further video, so keep watching the video till end and you will get an idea about the first order and second order of composite function, the third type of partial differentiation. Now moving on to the first subtype of the composite function is using first order derivative. Now for finding first order derivative, when my z is equals to f u of v, u and v are my variables and z is my dependent variable on u and v, which are independent variable. Now when I have to find dou z upon dou x, so how will I found my desired value dou z upon dou x, which is my intermediate step in my whole route, which I discussed in the introduction. So for finding that dou z upon dou x, we have a formula. For dou z upon dou y, we have a formula. So what are they? Dou z upon dou x can be calculated as dou z upon dou u into dou u upon dou x plus dou z upon dou v into dou v upon dou x. So I will get dou z upon dou x. Similarly, if I have to find dou z upon dou u, dou z upon dou v, dou z upon dou y, sorry for the mistake. Dou z upon dou y can be calculated as dou z upon dou u into dou u upon dou y plus dou z upon dou v into dou v upon dou y, and we will be getting dou z upon dou y. After calculating dou z upon dou x, dou z upon dou y, we will substitute in the root. So I will get half of the root, like I will get dou z upon dou x. Now after doing this, I will take the derivative and get the required answer. So it will help me to get through the half of the step, that is reaching the intermediate step. But after intermediate step, we have to take the normal derivative. So keep in mind this and you will understand about the composite function of first order. I will take an example, so keep watching the video and you will get a clear idea about the first order composite function of partial differentiation. Instagram page and get notes on our Facebook and Instagram page. So you can download it and yes, share it among your friends because a friend in need is a friend indeed. So like, share, subscribe my video and keep watching.